Hi all, welcome to the next topic of Unit 2, Program Control Instructions. Coming to the contents, we are going to discuss about an introduction to what are program control instructions and what are the different types of program control instructions available in the computer. So coming to the introduction of program control instructions, as we know, if a program contains a set of instructions, all the instructions of a particular program are stored at successive memory locations in the memory. So when the particular instructions need to be processed in the CPU, the instructions are fetched from the consecutive memory locations and executed by the CPU. So each and every time an instruction is fetched from the memory, the program counter, which contains the address of the next instruction, has to be incremented so that it contains the address of the next instructions according to the program order. So that is how instructions are normally executed, which are being stored in the memory locations, successive memory locations. Coming to a program control instructions, these are also a type of instructions when executed may change the address value of the program counter and cause the flow of control to be altered. So normally if in a normal execution of an instruction of a program, when a particular instruction is being executed, the program counter contains the address of the next instruction that has to be executed by the CPU. So whenever a program control instruction is encountered in a program, what happens is it may when that particular instruction is executed, it may change the value of the program counter, which means it is going to cause the flow of control of the program to be altered. So in other words, we can also say that the program control instructions specify the conditions for altering the contents of the program counter. So rather than executing the next instruction according to the program order, which is specified by the program counter, because of executing this program control instruction, it may change the order in which the instructions need to be executed in the program. So those type of instructions are said to be called as a program control instructions. So the change in value of the program counter as a result of execution of a program control instruction, it causes a break in the sequence of instruction execution. Other than executing the instructions according to the program order, it causes a break in the sequence in which they are being executed. So rather than if you take a set of 10 instructions in a program, say the CPU is currently executing instruction I2 and the PC points to instruction address of the instruction I3. So consider I2 is a program control instruction. So maybe the target instruction of that particular instruction is I8. So after I2, rather than executing I3, the program counter contains the address of instruction I8. So it is breaking the sequence in which the instructions have to be executed by the CPU. So that is the role of a program control instruction. So this is one of the very important feature in a digital computer because it provides control over the flow of the program execution and capability for branching to different parts of the program. So if you want the control to be moved from one part of the program to other part of the program, in case of a subroutines, in case of a functions, in that case we implement the program control instructions in our program in order to change the control of your program. So if we take a list of the program control instructions that are available, these are the list: branch, jump, skip, call and return, compare and test. So these are the list of program control instructions, and these are the mnemonics that are used for branch instruction: jump, escape for skip, call and return. Same for call it is same, return it is RET, compare is represented by CMP and test is represented by TST. So compare is used for by performing a subtraction operation on two operands, whereas test is done by performing an AND operation on two operands. So let's see each and every instruction in detail. The first type of a program control instructions are branch and jump. So branch and jump both are same type of instructions. So we are referring together. So this branch or a jump instruction is basically a one address instruction. The address part of an instruction format contains a single address and that represents the target address. So if it is written in assembly language as BR, ADR. BR represents branch, ADR represents the a symbolic name of an address in which it has to be branched to. So when this particular instruction is executed, the branch instruction, it causes a transfer of the value of ADR into the program counter. So after executing this branch instruction, the next instruction that has to be executed, the target instruction address is stored in the ADR that is loaded into the program counter so that the CPU control goes to that particular target address and start executing that particular address of your memory, which is stored in the memory. So since the program counter contains the address of the instruction to be executed, the next instruction will come from the location ADR. So the branch and jump instructions also can be a conditional instructions or unconditional instruction. It can be a conditional branch or conditional jump or unconditional jump. If it is an unconditional branch instruction, there is no need to check for any condition. It causes the branch to the particular specified address without any checking condition. So if it is an unconditional branch, the target instruction which is specified in the address part is the next instruction that will be executed by the CPU and the program counter points to that particular address. A conditional branch instruction, in case of a conditional branch, it specifies a condition such as branch if positive, branch if zero. So it depending upon that particular condition, if the condition is met, the program counter is loaded with a branch address and the next instruction is taken from this particular address. If the particular condition is not met, the program counter is not changed. So according to the program sequence, the next instruction is taken from the next location according to the program sequence. So this is about branch and jump instructions. So if you see this table, this will give you the list of all the conditional branch instructions because we are checking the condition here. Branch if zero, so there are certain status conditions called Z, C, S and V. Z stands for zero flag, C stands for carry flag, S stands for sign bit and V stands for overflow. So based on the particular condition, these flag bits, we are going to decide whether to branch or not branch. So this next two is with respect to the operands. Based on the value of two operands A and B, if A is greater than B, A is greater than or equal to B, based on the condition, the branch will be taken or not taken. So these are the list of conditional branch instructions. Next type of an instruction, program control instruction, is a skip instruction. This skip instruction, it doesn't require any address field. So we call this particular instruction as a zero address instruction. So in our instruction format, if there is no address specified as a part of an instruction, we call it them as a zero address instruction. So the skip is a zero address instruction. So a conditional skip will skip the next instruction if the condition is met. So what happens? Say for example, you have 10 instructions in your program I1 to I10 and the CPU is currently executing a conditional skip instruction which is I2. So if I2 is being executed, the program counter points to the next instruction, address of the next instruction which is I3, right? So whenever this condition is met, what it will do is it will skip the next instruction according to the program order. So rather than executing I3 instruction, the program counter will skip the I3 instruction and the PC will now points to the address of the next instruction which is I4. So the PC will be incremented by 1. So now the PC contains the address of the instruction I4 by skipping the previous instruction I3. So that is called a skip instruction. So that is in case of a conditional skip if the condition is met. This is how do you accomplish it? By incrementing the program counter during the execute phase rather than in the fetch phase of the instruction cycle. If the condition is not met, the control proceeds with the normal execution according to the program order. So the next type of a program control instruction is a call and return. So this call and return instructions are mainly applicable in case of a subroutines. So subroutine, what do you mean by a subroutine? A subroutine is nothing but it is a self-contained sequence of instructions that performs a computational task. So, say for example, with in a program you have a function that is called as a subroutine. So, during the execution of a program, a subroutine may be called to perform its function more number of times at various points in the main program. So each time a subroutine is called, the control has to be executed to the particular beginning of the subroutine, and it has to execute the subroutine instructions. It contains some set of instructions. So it starts executing the set of instructions. So after a subroutine has been executed, the branch is made back. So the control has to come back to the main program where it has left, and then it has to continue with the execution of the remaining program. So that is this is done by means of two instructions call. This is done by means of call and return instructions. So there are different names for this. You can use call subroutine, jump to subroutine, branch to subroutine, branch and save address. So all these are different names used. In general, we use as call and return instructions. So the call and return instructions, they perform two operations basically. The first operation is whenever a subroutine is called. So whenever calling function, uh, uh, whenever the subroutine is called, the address of the next instruction according to the program order, PC contains the address of the next instruction. So the address of the next instruction available in the program counter has to be stored at some location, temporary location, so that after the execution of the subroutine is completed, when the control go to the particular subroutine and it completes executing the control has to return back to the main program. So it has to know the return address. So whatever address which is stored in the program counter is now called as a return address. So the address of the next instruction available in the program counter, it has to be stored in a temporary location so that subroutine knows where to return back. So this particular instruction is called as call instruction. So control has to be transferred to the beginning of the sub. Now that after this point, the control will now be transferred to the beginning of the subroutine. And after the last instruction of every subroutine, we have a return statement, return from the subroutine. So it transfers the return address from the temporary location into the program counter. So whenever it reaches the end of the subroutine where it contains a return, whatever address is stored in the temporary location, that is stored into the program counter. So that the control goes back to the particular instruction where it has stopped. It transfers the control of the program to the instruction whose address was originally stored in the temporary location. So that is called as a return. So using call and return, the subroutine works. So these two instructions are considered as a program control instructions. So in for storing this return address, different computers use different temporary locations for storing the return address. Some computers, they use the first location of the memory, the zeroth location of the memory uh, for subroutines. Some stored it in a fixed location, some address, a fixed address in the memory. Some use it store it in a processor registers, and some computers, they store it in a memory stack. But the most efficient approach is to store the return address into a memory stack so that you can easily push and pop the particular address from the top of the stack. So a subroutine call is implemented on this by when you store it in a stack. How a subroutine call is implemented is you are going to decrement when your stack pointer points to the number of items on the stack, right? So whenever you are pushing an item into the stack pointer has to be decremented by one. So the stack pointer will be decremented by one, and whatever value is there in PC, that has to be loaded into the stack pointer. So this is done by means of a subroutine call. So PC contains an effective address. We are going to decrement the stack pointer and push the contents of PC onto the stack. Next, we are going to implement subroutine return. Sorry, this is not call. This is return. So the subroutine return is implemented using two micro operations. So first you are going to pop the stack, whatever is there on top of the stack, which is the return address, that it should be popped onto the popped out of the stack and transfer it into the program counter. whenever the control has to move from the subroutine back to the main program, you have to first pop the stack, get the particular return address from the top of the stack and transfer it into the program counter. And now you need to, since you have deallocated the memory space of the stack, you have to increment the stack pointer by 1. So this is called subroutine return. So the next type of program control instructions are compare and test. So the compare and test instructions, they do not change the order or sequence of the program directly, but they perform some manipulations between the operands, and based on the manipulations, they are going to set some status bits. So if you consider take the compare instruction, the compare instruction performs a subtraction operation between the two operands. But the result of the operation is no, we are not going to do anything with the result. However, based on the operation, we are going to set some status bits. So similarly, in the test instruction also, it performs a logical AND operation of two operands. And based on that, here also we are not going to retain the result or change the operands. We are going to set some status bits. Based on the status bits, there are certain status bits such as carry bit, sign bit, zero bit, overflow bit. So based on these status bits, they are stored. These status bits are stored for doing further analysis. So the status bits, we call them as also as a conditional code bits or a flag bits. So this sign bit, carry bit, zero bit, and overflow bit, these are called as a status bits. So it is sometimes very convenient with this ALU circuit has to be equipped internally in the CPU with a status register where the status bit conditions are stored and which are used for the further analysis. So if you see the diagram, this is our ALU circuit which is responsible for storing which contains a status register, which contains a set of status bits, the carry bit, sign bit, zero bit, and overflow bit. V stands for overflow bit. So it performs, this is a compare instruction which performs an subtraction operation on it takes two operands A and B which are 8 bits and perform a subtraction operation, and which gives you the output from F0 to F7. And based on the output, we are going to analyze the particular analyze the output bits from F0 to F7, and based on this we are going to set the status bit, set or clear the status bits. We will now see what are these particular status bits clearly. So there are 4 status bits which are symbolized by C, S, Z and V. C stands for a carry bit. So this carry bit is set to 1 if the end carry C8 is 1. It is clear to 0 if the carry is 0. So if there is, so if you consider the output of A and B, the subtraction operation output as of A and B as C0 to C7, if there is also a carry at bit C8, so ninth bit, if you get an extra bit out of an subtraction which is C8, if this bit, if there is any carry out of the particular subtraction, this bit C is set to 1. If the end carry C8 is 1. And it is clear to 0 if the carry bit is 0. So next bit is a sign bit. Sign bit is set to 1 if high order bit F is 1. It is set to 0 if the bit is 0. So based on the high order bits, if the high order bit is 1 out of the output, if the high order bit is 1, it is set to 0. And if the bit is otherwise, it is set to 0. Next bit is a 0 bit. So 0 bit is set to 1 if the output of ALU contains all zeros. So if the result of a subtraction operation is all zeros, then Z is equal to, the Z bit will be set to 1. If any one of the bit of the result is a non-zero value, which means it is a 1, then this Z is set to 0. Next is the overflow bit. Overflow bit is set to 1 if the exclusive OR of the last two carries are equal to 1. So if you perform an exclusive OR operation on the last two carries, which is F6 and F7, if it is exclusive OR operation, gives you 1 result 1, then this bit will be set to 1, which means that there is an overflow, and otherwise it is cleared to 0. So the status bits are checked after an ALU operation. So to determine certain relationships exist between the values of A and B. In case of compare, we are performing a subtraction operation, and in case of test, we are performing an AND operation. So based on these two operations, the status bits are set. Status bits can be checked after this particular operations to determine certain relationships between the two operands A and B. So for example, if the bit V is set after an addition of two signed numbers, it indicates that there is an overflow. If Z is set after an exclusive OR operation, it indicates that both the operands A and B are equal. Only when both A value and B value are equal, if you perform an XOR, you will get all zeros. So based on, if you want to identify the relationship between the operands, based on the status conditions, uh, you can determine the relationship between the operands. So this is about the compare and test instructions. Thank you.